Okay, I just want to go through this thing with you because I think it'll be really helpful. So we want to draw the fields around all of these different situations, all of these configurations of charges. So first of all, this is a positive point charge. So here's what it means. It's a positive charge. By point charge, what it means is that we're just considering that it has no size. Okay, if we had to say that it's like 4 meters across or something like that, then the field gets really complicated to draw. So we're saying that all of the fields that we're drawing are around charges that have no size, basically, even though it looks like this is a circle. So if this is a positive charge, it is going to repel other positive charges. Now remember that we draw fields in the direction of the force on a positive charge. So this positive point charge would repel other positive charges, and so the field that we draw around this would point outward. Okay, so the field around this charge is the area in which other charges experience a force. So all of this area, other charges are experiencing a force, and specifically we're drawing it as though they are positive charges. So positive charges would be pushed away from the central positive charge. So then if we look at the negative point charge, that's like this, it's negative, it will attract positive test charges. It'll attract positive charges in the area. So positive charges in the area would experience an inward force. So then the field around a negative point charge looks like this. Oh boy, that arrow was bad. Okay, positive charges in the area would experience an attractive force. So that's what it looks like. Two equal and positive charges. So these are both positive charges. Okay, and the field around a single positive charge, we know what that looks like. It looks like this one over here. That's a single positive charge. But a double positive charge, both of them in the same area, their fields are going to interact with each other. They're going to add together in certain places. Okay, so I'm going to start on the outside like this. Okay, those ones are just going to be as they are. But then when we draw the field inside the two, we can't just draw it like this, because although that field line is true for this positive charge, for the left positive charge, it is not true for the right positive charge, because a positive test charge over here, a little positive guy, we're saying that now it's going to experience a push to this thing, but that's not true because this one is also repelling that charge. So what we actually need to do is combine the two fields in the middle. Okay, and this is what that looks like. Let me just get rid of this really quick. Okay, now here's what that looks like. So they start to curve. Like that. Okay, and the same thing on the bottom side. Like this. Okay, so if you would put a positive test charge in the middle over here, it would experience the exact same repelling force from both of these sides. So it would end up experiencing no net force altogether. Okay, but if you would put your positive test charge, let's choose a different color here. If you would put your positive test charge over here, let's say, it would experience a repelling force from this charge, and it would experience a repelling force from this charge. It's closer to this one, so this is actually a bigger force than this force. The distance is just greater. So when you put those two together, you end up with this force from the closer positive charge and this force from the farther away positive charge, sorry. And so altogether, the field should point in that direction-ish. Okay, and that's what we see over here, that the field line that it's sitting on is just a combination of what's happening from both of those charges. Okay, but that you don't really need to, that's why we draw field lines like we do, but you really just need to remember how they're drawn. Okay, so that's the middle part of the fields, and then all around it just kind of goes like this. They're curved. Just like that. Something like that. There you go. And then when we do the negative charges, it's going to be very similar. It's just that instead of pushing charges outward, they pull positive charges inward. Okay, and so then these lines on the inside, they're going to look exactly the same as in the diagram we just drew, like this. Oh boy, I can do that better. Here we go. Okay, it's just that now instead of pushing them outward, they are attracting positive test charges inwards. So all our field lines are just pulling in. Okay, I didn't draw as many field lines here, but how many you draw isn't very important unless you are trying to draw so few that you can't even tell what shape the field is anymore. So my rule of thumb is don't be lazy and try and cut corners, but you also don't need to worry about have I put in enough. Just make sure that you draw what the shape looks like. Okay, and the last two here. Two equal but opposite charges. So let's say this one's positive and this one's negative. Okay, so let's imagine that we're putting a positive test charge right in the center, and we're going to figure out what it does right over here. So here's our tiny positive charge. It's going to be repelled from the positive charge over here and attracted to this negative charge. Okay, so remember that a field line shows the direction of the force on a positive charge. And so this is actually a little bit simpler than the shape of the other ones. So the shape of this one in the center just looks like this. Okay, and then all the field lines from this positive one are going to attempt to make it to the negative one. It's just that we always have to draw them perpendicular coming out of it, and so that's why they curve. So we have to draw our field lines starting out perpendicular. I'm going to draw a whole bunch of them apparently. Whoops. We have to draw them coming out perpendicular like that. But then when we connect them, there's not going to be like a corner in the middle. They're going to nicely curve into each other like this. Pointing that way. This one. Pointing this way. And they all make these loops. Except for the one that's pointing straight out this way. There you go. So that's what the field diagram looks like around opposite charges. And our final diagram over here is oppositely charged parallel plates. Okay, this one's a bit unique because there's charge that's spread out along this plate and it's the same everywhere. That's how charge works, where if it's a metal plate, the charge is going to spread itself out over the entire surface. Okay, same thing with the bottom plate. This one's going to be negative charge. Not sure if I fixed that on your copy, but this is a negative charge plate. And so now we're thinking to ourselves, we're putting a positive test charge in the middle. What direction does it go? So if we put our positive test charge in the middle, over here, positive, it's going to be repelled from the top and attracted to the bottom. Okay, and so that means that the field lines are going to go like this. Okay, and it doesn't really matter where you look in between the plates. Any charge you put in the middle of them is always going to do the same thing. It's always going to just move straight from the top plate to the bottom plate. Okay, and it's going to be the same everywhere. Let me just throw in one more here. So this is the field diagram for parallel plates.